This video is an introduction to implicit differentiation, where we will be doing examples of how to use implicit differentiation to find dy dx. Example 1, we are going to find dy dx for the curve x plus y squared equals 1. When using implicit differentiation, rewrite the entire equation, x plus y squared equals 1. I'm finding dy dx, so x is my variable of differentiation. I'm going to put brackets around the entire equation and put the operator d dx out front to indicate that I'm about to take a derivative. The next thing I need to consider is P, Q, C, product, quotient, chain. We always want to consider whether the product, quotient, or chain rule will come into our derivative. X is a term by itself. There's no multiplication or division there. Y squared, now I don't see multiplication or division, but since x is the variable of differentiation and this is y is a function that is being squared. This is a chain rule, and then 1 is just a constant. After we've considered P, Q, C, we're now going to take a derivative of each term. The derivative of x with respect to x is 1. Plus, now y and x are different variables, so I'm using a chain rule here. 2y, the inside stays the same, to the first power, times dy dx. Whenever you're differentiating y, you will multiply by dy dx, equals the derivative of 1, which is a constant, is 0. Now the question asked me to find dy dx. It's right here, but I need to isolate it. There are 2 terms. Any term that does not have dy dx moves to the right. Everything else stays on the left. I'm going to subtract 1 from both sides. At this point, my equation says 2y dy dx equals -1. In order to solve for dy dx, 2y is being multiplied. I need to divide by everything that's not dy dx. Divide by 2y. Whatever you do to one side, do to the other. My final answer is dy dx equals -1 over 2y. Now, you try. Find dy dx for the curve y cubed minus 2y plus 2x equals 0. At this point, you should pause the video and work out the problem on your own. By this point, you should have paused the video to work out the problem to find dy dx for y cubed minus 2y plus 2x equals 0. I'm now going to show the solution. So the first thing we did was rewrite the entire equation and put d dx out front. We considered P, Q, C. There are no products or quotients here, but there is a chain rule with y cubed. Let's see. We took the derivative of each term. The derivative of y cubed is 3y squared dy dx. The derivative of 2y, now this is 2y to the first. The derivative of 2y is 2 times the derivative of y, which is dy dx, plus the derivative of 2x is 2. There are 3 terms in this expression. Only the final term does not have dy dx. So we subtracted the term that does not have dy dx to the right-hand side, which gets us to this line here. Now I have 2 terms with dy dx, so I use GCF factoring to bring dy dx to the front. What remains is 3y squared minus 2 times dy dx equals -2. Finally, you divide by what you factored dy dx out of, and your final answer is dy dx equals negative 2 over 3y squared minus 2. Let's move on to another example. Example 2, find dy dx. Example 2, find dy dx for 6x cubed plus 7y cubed equals 13xy. So the first thing that I'm going to do, as always, is rewrite the entire equation. 6x cubed plus 7y cubed equals 13xy. I'm going to put brackets around the whole thing and dx out front. Do not skip this step. P, Q, C. Looking around, okay, I have a y, so that's definitely a chain rule. I'm going to put parentheses to indicate a chain. But here, I actually have a product. This is 13x times y. So before I start differentiating each term, I'm going to deal with this product. I'm going to write my u's and v's. U is 13x, v is y. U prime, we're differentiating with respect to x here, so u prime is just 13. I don't need dx because that would be 1. And v prime, the derivative of y, that's dy dx. So now that I've considered p, q, c, I'm ready to differentiate each term. I'm going to start with 6x cubed. Power rule as always, the derivative of 6x cubed is 18x squared. Plus, now I'm differentiating with x, but here's a y, so this is a chain rule. 7 times 3, that's 21. Inside, which is y, stays the same, squared, times the derivative of y, dy dx. Every time you take the derivative of y, you multiply by dy dx. Equals, now I do have this product rule here. I'm going to do u prime v, v prime u. So I've got 13 times y plus u prime v, or uv prime, which is 13x, times dy dx. Now my goal is to find dy dx, but everything's kind of messed up here, all in different orders. I have 1, 2, 3, 4 terms. 2 of the terms have dy dx, and 2 of them do not. The terms that do not have dy dx need to go to the right, and the terms that do will go to the left. I'm going to do this all in one step. 18x squared does not have dy dx. That's going to move over to the left, minus 18x squared. Whatever you do to one side, do to the other, minus 18x squared. This guy's okay. It's got a dy dx. The 13y, that's on the right side. That's good. But here I've got 13x dy dx. That's going to subtract over to the left now. So minus 13x dy dx. Whatever you do to one side, you do to the other. Minus 13x dy dx. I'm just rearranging my terms at this point. I'm still going to have 4 terms here. So I'm going to have 21 y squared dy dx minus 13x dy dx equals 13y, that's this one, minus 18x squared. So 1, 2, 3, 4 terms. All my dy dx's are to the left. I'm now going to factor out dy dx. Dy dx times 21y squared minus 13x equals 13y minus 18x squared. Now, to get dy dx by itself, I'm going to divide by 21y squared minus 13x on both sides over 21y squared minus 13x. My final answer is going to be dy dx equals 13y minus 18x squared over 21y squared minus 13x. Now that we've done some examples, you try. You're going to find dy dx for the following two curves. At this point, you should pause the video and you should try to work these out for yourself before the answers are revealed. By this point, you should have paused the video and worked out the problems on your own. I'm now going to reveal the answers with some of the steps. Here are the answers to questions 1 and 2. Thank you for watching.